Dear students, welcome back to this session. In the previous session, we were discussing the features of normal distribution. We studied 7 features of normal distribution in the previous class. Now let us study to the next feature. Let us have a glance of those 7 features. First, features of normal distribution. First one, it is a bell-shaped curve. Also second one, it is symmetric about mu, that is a beta 1 equal to 0, or since it is symmetric we can say mean, median and mode are equal. And similarly third one, it is unimodal. Normal distribution is having a unique mode and mode is given by mu itself. So mu represent mean, median as well as mode of the normal distribution. Next is it is a mesocurtic curve, that is not highly peaked, not less peaked, peaked on an average, beta 2 equal to 3. Similarly, standard deviation is given by sigma, quartile deviation equal to 2 by 3 sigma, mean deviation is 4 by 5 sigma. And normal curve is asymptotic to x-axis. That is, the normal curve touches the x-axis only at minus infinity and plus infinity. Similarly, the points of inflection of a normal curve are mu minus sigma and mu plus sigma. That is the position where the curve changes its directional movement. Those positions are called as points of inflection. Next, next feature is based on the moments. Moments, that concept we studied in first PU under the heading moments, kurtosis and skewness. Generally moments are represented by the notations mu1, mu2, mu3 up to mu so on, that is infinite moments. So mu1, mu2, mu3 etc. are the notations used to represent the moments. Next, here there are 2 categories of moments. Mu1, mu3, mu5, mu7, those are called as odd order moments. Similarly, mu2, mu4, mu6 etc. are called as even order moments. Here remember, in a normal distribution always the odd order moments are equal to 0. Odd order moments are equal to 0. That is, mu1 equal to mu3 equal to mu5 so on, which is equal to 0. Similarly, even order moments are given by the formula. Even order moments are given by the formula mu2r is equal to 1 into 3 into 5 into so on up to 2r minus 1 into sigma power 2r. This is the formula to use to find the even order moments. That is, the values of mu2, mu4, mu6 etc. can be calculated with the help of this formula. For example, now consider r is equal to 1 by substituting the different values for r, that is r equal to 1, 2, 3 so on, we can find the even order moments. Now put r is equal to 1 first in this formula. Then mu2, 2 into 1, 2r, 2 into 1, that is mu2 is equal to, first always decide the value of this factor 2r minus 1. So if r is equal to 1, what is 2r minus 1? Which is equal to 2 into r is equal to 1. So 2 into 1 minus 1. So 2 into 1, 2 minus 1, which is equal to 1. So the factor 2r minus 1 is 1 if r is equal to 1. So here start the product from 1 and end with the 1. So only 1 we have to consider here. The next factor is sigma power 2r, 2 into 1, 2. So value of mu2 is that is the second order moment is given by sigma square. Right, mu2, that is even order moment, right? Second order moment, mu2 equal to sigma square. Similarly, put r is equal to 2. Then mu 2 2r, 2 into 2, 4, which is equal to, once again, get this factor first. 2r minus 1, 2 into r is 2 minus 1. That is 2 into 2, 4, 4 minus 1, which is equal to 3. So, start from 1, end with the 3. The last value is 3 itself. So, 1 into 3 into sigma power 2r. 2 into 2, that is 4. The answer is 3 sigma power 4. Similarly, by substituting, put r is equal to 3. What do you get? Mu 2 into 3, 6, which is equal to, first find this value, 2r, 2 into 3 minus 1, 2 into 3, 6, 6 minus 1, 5. So, start from 1, multiply next 1, 3, end it with the 5. Right? Next, sigma power 2r, 2 into 3, 6. This is 5 into 3, 15 into sigma power 6. Is it clear? This is the way of calculation. Next, r is equal to 4, r is equal to 5. Now, suppose I want to find r mu 10. Yes, I want to find mu 10. It is even order moment. Now, put r is equal to 5. 10 divided by 2, 5, right? So, 2 into 5, 10, which is equal to, start from 1 into, first find 2r minus 1. Yes, 2r minus 1, that is 2 into 5, 10, 10 minus 1, 9. So, last factor becomes 9. So, here 1 into 3 into 5 into 7 into 9 into sigma power 2r, 2 into 5, 10. Now, multiplies all those. So, 5, 15 into 7, 105 into 9, 945 into sigma power 10. What is a frequency curve? Frequency curve is obtained by considering the frequencies along y-axis and the values of variable along x-axis. In the similar manner, probability curve is obtained by considering probabilities along y-axis and the values of random variable along x-axis. Here, we know now what is the normal curve or the probability curve of a normal distribution. We have seen this in the previous session. At the center there is a mu, right? And here along x-axis, this is a x-axis. Here we are going to consider the values of normal variate. So, the x values will be considered along x-axis, and here there is actually y-axis. Along y-axis probabilities will be considered, and hence these heights, there are many heights we can consider here. All those represents heights of curve. And those heights, among those heights we can observe this is the maximum height, right? This is the maximum height, and hence we can say the maximum probability occurs at x is equal to mu. So, in a normal distribution, the maximum probability occurs at x is equal to mu. Then, what is the maximum probability? For that, just consider the probability density function f of x is equal to 1 by sigma root 2 pi e power minus half into x minus mu by sigma whole square. X lies between minus infinity to infinity. Now, here put x is equal to mu, because we are studying at this point what is the probability, we have to check. For that, put x is equal to mu. So, here you will be getting mu minus mu, which is equal to 0. So, 0 by sigma, 0. So, once again you will be getting this term as 0. 0 square, 0. So, e power minus half into 0, 0. So, e power minus 0 is a 1. So, totally you can observe if x is equal to mu, this term becomes 1. So, here we can write 1 by sigma root 2 pi. When you will get this, if x is equal to mu, we are going to substitute. Therefore, we can say this is the maximum probability. This is a maximum probability. Therefore, the next feature we can write the maximum probability occurs at x equal to mu. In a normal distribution, the maximum probability occurs at x is equal to mu, and the maximum probability is f of x maximum is equal to 1 by sigma root 2 pi. 1 by sigma root 2 pi. This is the maximum probability in a normal distribution. Okay. Next, let us study a very important feature based on area. This feature is called as the area property of a normal distribution. Area property of a normal distribution. Now for that, consider a normal curve. Here, this shaded region, it is a normal curve. Remember, in a normal curve, I have shaded some area. This is the area under the normal curve above the x-axis, right? So, the region between the normal curve and the x-axis that I shaded, this area is called as a area under the normal curve. Area under the normal curve. Now, this area under the normal curve is considered as 1. Why? Since a normal curve is a probability curve, and also in any situation the total probability is equal to 1, here the area under the normal curve is considered as the total probability, which is equal to 1, right? So, which concept we are going to use here? That is the area under the normal curve, which is equal to the total probability, which is equal to 1. So, remember, this area is considered as 1. It do not have any unit of measurement since it represents the probability, it is just 1, right? So, here we can write the feature as the total area or the area under the normal curve. The area under the normal curve is 1. Area under the normal curve is 1, right? Next, since this distribution, that is a normal distribution, is a symmetric distribution. Now, if we are going to get a perpendicular at the point mu, then we can say both these halves coincide since it is a symmetric. And since the total area is 1, we can say the area to the right of mu, which is equal to the area to the left of mu, which is equal to half of the total area, right? Half of the total area. What is total area? 1. So, what is half of total area? Half of 1, that is a 0.5. Therefore, we can say in a normal distribution, the area to the right of mu, that is this area, is equal to area to the left of mu, that is this area, which is equal to half or 0.5. This is one more very important note you must keep in mind. Next is, we know how to get a normal curve with the different points, some specific points. The curve will be like this. Here at the center, I have to write a mu, right? This is a mu. Then to the right, 3 more points. Mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. And this is a infinity. Mu minus sigma, mu minus 2 sigma, next mu minus 3 sigma, right? This is called as a normal curve. Here, let us see first how to represent the probability of a normal variate takes some values, that is maybe normal variate less than, greater than, or in between two values. How to represent those probabilities in terms of a normal curve? Let us see that. That is, probability of x lies between A and B. Probability of x lies between two values of x, A and B. It can be represented in a curve like this. Now let us consider A and B along x axis. I am going to consider A here and B here. Now, what is A and B? Those are the different values taken by a normal variate x. In a particular example, it may be 20, 30 and so on. Next, I want to find the probability of a normal variate x lies between these two values. That is, the probability of a normal variate x lies between A and B. How to present it here? That is, get a perpendicular at those 2 points. Now, the probability of a normal variate x lies between these two values is nothing but the area under the normal curve between two values A and B. That is, this region indicates the probability of x lies between A and B. That is, there the shaded area represent the probability of a normal variate x lies between A and B. Is it clear? This is how to use area under the normal curve to find the probabilities in a normal distribution. So, we can write here probability of A less than x less than or equal to B is equal to area under the normal curve between two values or ordinates x equal to A and x equal to B. This is the presentation of probability in terms of area in a normal curve. I think all of you are following this. Next, let us see some additional factors on area. Now, we have some points here in a normal curve, that is a mu plus sigma, mu plus 2 sigma, mu plus 3 sigma to the right of mu. Similarly, some factors like mu minus sigma, mu minus 2 sigma, mu minus 3 sigma to the left of mu. Those points look like the neighbors of mu, right? So, here actually in normal distribution, we are going to call mu minus sigma and mu plus sigma as a sigma limits. So, mu minus sigma and mu plus sigma are considered as a sigma limits. Sigma limits. Similarly, mu minus 2 sigma and mu plus 2 sigma are called as a 2 sigma limits. And what about third one? Mu minus 3 sigma and mu plus 3 sigma. Those are called as 3 sigma limits. Right? Sigma limit, 2 sigma limits and 3 sigma limit. Suppose there is another factor somewhere in between, mu plus 0.5 sigma, another one mu minus 0.5 sigma. Those are called as 0.5 sigma limits. This is the way of reading the values. Okay, next let us see how the probability of x, a normal variate, lies between 2 sigma limits can be represented in a normal curve. That is, I want to find the probability of a normal variate x lies between these two values. Now, for that, get a perpendicular at those points first, right? Then shade this region. Now, this is the required region which represents the probability of a normal variate x lies between mu minus sigma and mu plus sigma. It is equal to the area under the normal curve between two values mu minus sigma and mu plus sigma. Is it clear? Now here this is called as, right, this probability or this area we can say as a sigma neighborhood of mu. That area is said to be sigma neighborhood of mu, right? Similarly, next we can move to the next set of points. So before that, let us write that feature. First one, this is called as a area property. Okay, area property. Now first one, probability of x lies between sigma limits mu minus sigma and mu plus sigma. What is this area? It is given under normal theory 0.6826. That is, if the total area under the curve is 1, then out of that 0.6826 area lie within those two values. So what is this area? This area indicates 0.6826. Or suppose, for better understanding, if we are going to consider there is a or the total area under the normal curve is 100%, then out of that 68.26% of the area is present in between mu minus sigma and mu plus sigma, or the probability of a normal variate x lies in the sigma neighborhood of mu is 0.6826. This is the meaning of this statement, or we can represent this in terms of percentage. Similarly, consider the 2 sigma limit. Then here get a perpendicular. Then what is the area lie between mu minus 2 sigma and mu plus 2 sigma? That is within 2 sigma limits. We can say this is the area present. The dotted region indicate the area between 2 sigma, the dot or area in between mu minus 2 sigma and mu plus 2 sigma. Which region? Dotted region. Suppose here the total area under the normal curve is 1. What is this area? This area, that is dotted area, is 0.9544. That is, we can write probability of x lies between 2 sigma limits. That is probability of mu minus 2 sigma less than x less than mu plus 2 sigma, which is equal to 0.9544, right? What it indicates actually? The probability of a normal variate x lie in the 2 sigma neighborhood of mu is 0.9544, or we can say the percentage area as 95.44. Similarly, look at the next set, mu minus 3 sigma and mu plus 3 sigma. Those are called as 3 sigma limits. So we can say here, get a perpendicular. Now this region indicator. So from this point to this point, this complete region indicate the area between the two values mu minus 3 sigma and mu plus 3 sigma. What is that area? That is that area is equal to 0.9974. That is a third feature, probability of x lies between 3 sigma limits is equal to 0.9974. In the percentage, we can write it as 99.74%. That is once again probability of a normal variate x lie in the 3 sigma neighborhood of mu is a 0.9974, or we can say 99.74% of the observations lie within 3 sigma limits. So only a small percentage is remaining, that is 100 minus 99.74, that is 0.26% of the observations lie beyond 3 sigma limits, right? Only, that is approximately we can say only 3% of the observations lie beyond 3 sigma limits. Now, we know there are two parameters in a normal distribution, mu and sigma square. If a random variable x follows normal distribution with the parameters mu and sigma square, symbolically we can write x follows normal in bracket mu comma sigma square. Is it right? Okay. Next, here in a normal curve, what are the values of q1, q3? What is q1 and q3? q1, q2, q3, those are called as partition values. And among those three, the middle one, q2, that indicate median. Median itself is called as a q2. And here, what is the value of q1 and q3? That is the next feature. q1, the first quartile, it is given by mu minus 0.6745 sigma. Similarly, q3, it is calculated with the help of the formula mu plus 0.6745 sigma. So, if mu and sigma are known, we can find q1 and q3. These are the features of a normal distribution. In a normal distribution, if mu equal to 0 and sigma equal to 1, then that distribution is called as a standard normal distribution. So, one more distribution we have to study, that is a standard normal distribution. It is not a separate distribution, it is a specific case of normal distribution. So, what is a standard normal variate? It is a very important 1 mark question. Define standard normal variate. Standard normal variate. A normal variate with z, capital letter Z, with mean mu equal to 0 and standard deviation sigma equal to 1 is called standard normal variate. Standard normal variate. Once again, I am going to repeat. A normal variate Z with the mean mu equal to 0 and a standard deviation sigma equal to 1 is called a standard normal variate. The distribution of Z is a standard normal distribution with the parameters 0 and 1. Right? Next, the probability density function of a standard normal distribution is given by the probability density function of a standard normal distribution is given by f of Z. Here we must write Z, the random variable is Z, standard normal variate, the notation used is Z. So, f of Z is equal to 1 by root 2 pi e power minus Z square by 2. Now, Z lies between minus infinity and plus infinity. This is considered as probability density function of a standard normal distribution. It is obtained by putting mu equal to 0 and sigma equal to 1 in the probability density function of a normal distribution. Okay. Next, one more important note, that is, if x is a normal variate with the parameters mu and sigma square, then always Z equal to x minus mu by sigma, it is considered as a standard normal variate with the parameters 0 and 1. That symbolically we can write it as if x follows normal with the parameters mu and sigma square, or if x is a normal variate with the mean mu and variance sigma square, then always z equal to x minus mu by sigma follows normal with the mean 0 and standard deviation 1. Right? Now, there itself, I am going to write what those different notations indicate. Now, here, what is x? This x is a normal variate. Is it right? What is z? It is a standard normal variate. Then, what this indicate? Normal mu comma sigma square. It is the notation which is used to represent the normal distribution. Right? It is the symbolic presentation which is used to write standard normal distribution. Remember, normal means n in bracket mu comma sigma square. Standard normal distribution means here we are not going to write s n d. Instead of that, in the same notation we are going to use, in place of mu write 0, in place of sigma square write 1, because a normal way distribution where mu is equal to 0 and sigma equal to 1, that distribution itself is called as a standard normal distribution. So, this is a very, very important, right? So, if you are going to study the standard normal variate, always remember the random variable we have to write is a z, it is not a x. So, everywhere while solving the problems, under normal distribution, at first the given normal problem is converted as a standard normal problem. For that we are going to use this factor, right? And this is about the standard normal distribution and standard normal variate. Next, let us just recall the features. That means already we know the features of normal distribution. Once you know that, easily we can write the features of standard normal distribution. How? In place of mu write 0. Similarly, sigma should be replaced by 1 in all the features which we stated under normal distribution. Now, first, for example, now see the first feature of a normal distribution. Here I am going to write features of standard normal distribution. Let us see one by one. First one, it is a bell shaped. This is also bell shaped curve, right? Standard normal distribution is also bell shaped curve. Then it is symmetric about mu. What about standard normal curve? Now here I am going to draw a standard normal curve. It is same as normal curve. The values we have to write in different manner. Now the range is minus infinity to infinity, and here actually in normal curve it is mu, but standard normal curve mu equal to 0. So at the center we must write 0. So we can say it is a symmetric curve, right? Standard normal distribution is a standard normal curve. Standard normal curve is a symmetric curve. Therefore, mean, median and mode are equal. That is a mean equal to median equal to mode equal to 0. So second one we can say mean equal to median equal to mode equal to 0, right? Next, the value of beta 1 equal to 0. Next, it is a standard normal distribution is also a unimodal distribution, and the modal value is mode equal to 0, median equal to 0, mean equal to 0. Next, it is a mesokurtic curve. Therefore, the value of beta 2 equal to 3. In the similar way, you can study one by one features. Next one, here standard deviation is a sigma in a normal distribution. What about here? In a standard normal distribution, standard deviation is 1. In place of sigma, write 1. What is quantile deviation? It is a 2 by 3 sigma. There, here 2 by 3 into 1. So that is 2 by 3. Next, mean deviation 4 by 5 sigma. Sigma is 1. So here it is a mean deviation equal to 4 by 5. And the next feature, sixth one, normal curve is asymptotic to x-axis. Here also standard normal curve is asymptotic to x-axis. It touches the x-axis only at minus infinity and plus infinity, same feature. The next feature, the points of inflection of a normal curve are mu minus sigma and mu plus sigma. I wrote here, right? Then in a standard normal curve, what are the points of inflection? Those are mu minus sigma. What happens to mu minus sigma? Mu is 0, minus sigma is 1. So 0 minus 1. Minus 1. So points of inflection are minus 1 and plus 1. Is it right? Mu plus sigma, 0 plus 1. So 1 mark question. What are the points of inflection of a standard normal curve? You must write a minus 1 and plus 1. For a normal curve, mu minus sigma and mu plus sigma. The maximum probability occurs at z equal to 0. Here, the maximum probability occurs at z equal to 0. It is not x. We are dealing with the standard normal variate. So put z equal to 0. Here along x-axis, z will be taken in a standard normal curve, right? And along y-axis probabilities. Next, what is the maximum probability? The maximum probability is 1 by square root of 2 pi. In normal distribution, it is 1 by sigma root 2 pi. So here it becomes the maximum probability is 1 by root 2 pi. Sigma is equal to 1. After that, area property. I wrote here. Now just to see this. In place of mu minus sigma, we will be getting minus 1 in a standard normal variate, because here mu plus sigma, see here, that is 0 plus 1, which is equal to 1. Mu plus 2 sigma, 0 plus 2 into 1, which is equal to 2. So here 1, 2, 3. Next, in the left side, mu minus sigma, 0 minus 1, which is equal to minus 1. Similarly, mu minus 2 sigma, 0 minus 2 into 1, minus 2. Similarly, minus 3. Now, it is a standard normal curve or the probability curve of standard normal distribution. So, here the probability of how to write these area property, right? These factors. Now just in a standard normal variate distribution, the first this part we can write like this: probability of z lies between minus 1 and plus 1, which is equal to 0.6826. What about this? In place of those two, I must write probability of z lies between minus 2 and 2. That is a minus 1 and plus 1. Yes, first one, sigma limits, 2 sigma limits, 3 sigma limits. The same thing we can write like this in a standard normal distribution. Only the presentation is different. The probabilities remain same, right? Okay students, thank you.